So we've got a group of university students designed a small rocket. They installed a tracker to record the statistical data of the flight. One particular launch looks as follows. We've got time and height. We know that the first one, right, the first row will be our x values and our y values. And for that reason, every single point of our resulting equation will be referring to time and height in that order, okay? So what determine the quadratic equation that would model the height over time, show your work. This is part of the work, and then you just go something like this, stat, calc, quadratic regression. Next year, or in grade 12, we do linear, quadratic, cubic, exponential, logarithmic, sinusoidal. There's 6 different ones we're doing next year.
Excuse the interruption. Sierra J to room 33, please. Sierra J to room 33.
So let's type that in. So this year it's going to be quadratic regression all the time, but next year not so much. So we go and maybe let's turn on plot 1. I'm going to try to zoom stat. Zoom stat is zoom 0. Why is this not working for me? Zoom, let's try that again. Zoom stat. There we go. So it looks like a straight line, but it is not. But at least now you have an idea where are these points. So we go stat, calc, quadratic regression. Some of you need to have this written down because for the test or quiz you need to know what to press, okay? And so that's my equation right there. I'm going to write that down. So that's negative 26.81 x squared plus 616.35 or 354, it doesn't matter. More than 3 is fine. Minus, I would round to 6 there. Not minus 6, plus 6, my bad. So that is your quadratic equation. You get a mark for that. If you get that wrong, even by a little bit, we take off a full mark here, but then we will honor everything that comes after. Then I would have to type in your equation and see if it matches, okay? So all or nothing here. The initial height of the rocket, you would say is 6 feet, right? It's the y-intercept that gives me that, 0, 6. So at time 0, we're at 6 feet, but you must state it with units like that. So we know which one we're talking about. So 6 feet is the initial height. How long did it take for the rocket to hit the ground? So again, if you have this, we know we start at 6 feet, we go up and then down. Okay, so we want to know this time here. So from time 0, from the launch till it hits the ground, what is that? That's my x-intercept. So I need to go y2 is equal to 0, second trace, intersect. Let me graph this. I haven't done anything with my window yet, so I'll do that. Not a good window at all. So I'm going to go window, -2, and -2 for my mins. Okay, try that again. Much better, but now I need to chase the curve. So I'm going to increase my x max for sure. Since it's 4, I'm going to go triple that maybe. That'd be about 15. Let's try that again. Still not good enough. I need to see it coming back down. X max 30. There we go. So X max, I see enough sideways. I need to go Y max, increase that now. I'm going to go 3,000. Still not good enough. What is it, 4,000? Let's try 4,000. There you go. That is a pretty good graph. Now you see everything. Let's go ahead and find that x-intercept there. So I let y2 equal to 0, hit graph. And we're going to go find that intersection. Second trace 5, go closer to that one, hit enter 3 times. That's 23, rounded, 23, 0. Okay? That's the point. The reason why I would suggest you always write down the coordinates is because you might need that for your graph. That's why I write down the coordinates. So the answer is 23 seconds. Obviously, this would be different if your equation is different. That's why you want to show your work. Okay? Because if I see, oh, okay, you know exactly what's supposed to happen, your equation is off, that's why your answer is off. So then when you see something like this next to your answer, step check mark, like if I might mark it wrong, but you see step check, that means that based on your work, this step is correct. okay? What's the domain and range of the situation? It's a word problem, so no infinities in this case. So from time 0 till we hit the ground, which is at 23 seconds. For range, we do hit the ground, so the lowest is 0, okay, 0, and the highest is given to me by the vertex, which is, do we know the vertex? We don't know the vertex. We have to find that. So let's go ahead and find that. This is a max, right? So second trace max. You're going to get a mark for this, by the way. Second trace max. My cursor is in the negatives. I can't even see it, so I have to bring it up, right? So there you go. To the left, to the left. Are you too young for that song, or do you still know it, right? 11:49, 11:49, 35, 48, 44. Okay, so this is the highest Y value that's applicable here, that is permissible. And so this is how we're going to do this. We're going to make this out of 3. Okay, this question is going to be out of 3, not out of 2. I'm going to give you a full mark for you having found the vertex, and then another full mark for actually stating the range correctly. Whether it's in set notation or interval notation, that's up to you. If you use set notation, in this case you could use x and y because you were not given an equation. Then you choose the variables that you want to go with. Okay, that's it. So what are we at? 3, 4, 5, 6. So we're out of 6 on this page. Give yourselves a mark out of 6. If you use round brackets, that'd be half off. If you use no brackets, I would say for sure half off today. Somehow pre-cal folks thinks they don't need brackets at all. Okay, so for set notation, but you need to have the squiggly brackets and applied. Okay, backside. We did this one, right, in class? You're welcome. You're welcome. This is just to see if you're actually paying attention. So at 110 plates, right, if we charge $5 a plate, that's 110 plates that we're selling. Every time we increase it by 50 cents, something happens to the number of plates, right? They go down by 8. I should have at least changed the numbers, right? Well, sometimes I'm lazy. Okay, 94. So you take away 8 every time, you increase 50 cents every time. You multiply across, you get 5, a little quieter, guys, 561, 564, if you multiply this, okay? So you get a mark for having this filled in correctly. Determine the quadratic equation relating the price and the profit. So price goes into L1, profit goes into L2. All right, so we go stat, calc, quadratic regression. And I'm going to do that here real quick. I should have prepared for this. So 550, 6, 550, 561, 564. I'm going to try zoom stat. It kind of shows the beginning of this thing. But right now, let's focus on the quadratic regression, the equation. And I did this already, so I'm just going to go ahead and, in my history, copy paste. It saves you a lot of time. So that's negative 16x squared plus 190x. That's all I care about on that one. You get a full mark for that. And of course, if you made a mistake up on your table, you lose the mark there, but you get a mark here based on your table. Okay. The only exception is if your parabola ends up pointing up, I will take off more marks, because you know that if there's supposed to be a maximum profit, this thing is just not going to give you a maximum profit, right? It just keeps on going up indefinitely. So that's something I would like you to catch. or a linear. Like let's say you get 0x squared. I'm like, sorry, it can't be. It has to be quadratic. It does tell you it's quadratic. So things like that would you would lose marks there. Let's see the whole thing. We cannot see it as is, so I'm going to go Window, my X and Y min. I'm going to change that to something negative right away. What did I do there? That's not negative. There. There we go. It's a little bit too much to the negatives and the X, but that's fine. X max, I'm going to triple that. I'm going to go to 20 maybe. And there you have it. So the maximum profit is found right at the top. Second trace max. Go to the left of the vertex. Go to the right of the vertex. There you go. So second trace max. The coordinates would be 5.94, 564.06. So the maximum profit is 564.06. Okay. How many plates are you expected to sell at this price? It's asking you for plates, so you can't use your quadratic equation. So you need to go plates is profit divided by the price. So basically these two numbers, if you divide them, you get the plates. Okay, so 564.06 divided by 594, that is 94.95, which is approximately 95 plates. When it comes to discrete data, you need to round it to a whole number. So people, coins, cans, we talked about that. Yes?
Isn't efficiency asking for the maximum, the price that will give the maximum profit?
Oh, yeah. Yeah. Joao got me. I know that you got me too, but you're just like, keep going. Dig yourself a little deeper of a hole there. Okay, yes. Price, thank you. Price is $5.94. See, I don't even need to come up with jokes. I just try to do math and then you laugh, right? So the price is this. That's what we're after, not the maximum profit. Okay. Thank you. Why are you so in a hurry, Mr. Erickson? Seems like you're rushing or something. What price or prices will give you a profit of 500? So we know 500 is the profit. So this is what 500 is, and they would want us to figure out the price, like what price would give you that. So you got to let y2 equal to 500, and then we go second trace intersect. That says intersect, I promise. And so we have our graph like this, and 500 is going to go somewhere in here. So there are two instances where you get that profit. I'm just going to go ahead and give you the answers, and you just check if you got that right. So this is 3.94 is one of them, and 7.94 is the other price. So a price of $3.94 or $7.94 will get you that profit of 500. Okay. So what are we at in terms of marks? Let's do that real quick. 1 for the table, 2 for the equation, 3 for the price, 4 for the number of plates, and another 2, so that's 6 in total for this backside.